This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect, then let's get started with your first mission. Hi there, welcome to the Conservation of Energy simulation. Here you will learn to calculate and manipulate potential, kinetic, and mechanical energy to improve the Labster roller coaster. Click Continue to start with your mission.
Welcome to the Labster roller coaster ticket booth. One perk of working here is all the free roller coaster rides. Hey, looks like one of our most enthusiastic customers is here again today.
I'm back. I love this Labster ride. I think I have enough money to go on the ride 5 times today.
Looks like you're right. You possess the capacity to go on the ride 5 times.
Exchange the money for 5 tickets.
The roller coaster transforms energy in the same way you transformed money into tickets. It begins way up here above the city with potential energy, which is then converted into kinetic energy as it zooms down the track.
You mean it gets converted into fun? I heard you guys are going to try and make the roller coaster go over 100 kilometers per hour.
We certainly are. You just bought tickets from the genius who is in charge of the improvements.
Click on the diagram of the roller coaster on the wall to go to the design lab. This is the roller coaster design lab. Here, you will use physics to improve the Labster roller coaster. The main tools we will use to improve our roller coaster are the concepts of energy and energy conservation. Energy is the ability to enact change in one's surroundings, or, more accurately, the ability to do work. There are many different types of energy, and the total energy of a system is the sum of all the different types. It is a fascinating feature of our universe that, no matter what we do, the total amount of energy in it always remains constant. Energy can change from one type to another, or pass from one system to another, but there is no way to remove energy from the universe or to create more than there already is. We call this the principle of conservation of energy. Although there are many kinds of energy, we will concentrate on just 2: gravitational potential energy and kinetic energy. Potential energy is a big bag in which we put all kinds of energy related to an object's state or its position relative to other objects. For example, its position above the ground. The gravitational potential energy of an object close to Earth's surface is the energy it has because Earth's gravity pulls on it. Any object at a certain height has the potential to fall down because of gravity and affected surroundings with the fall. Let's use our equation builder to find a formula for the gravitational potential energy of an object near Earth's surface. Select the cards with the variables that you think influence gravitational potential energy and place them on the screen. Well done. Now let's do the same thing for kinetic energy. Kinetic energy is the energy of motion. It is the work needed to bring a body starting at rest to a certain speed. Select the cards with the variables that you think influence kinetic energy and place them on the screen. Perfect. The equation of kinetic energy depends on mass and speed. However, the formula is not as straightforward as it is for potential energy. To understand how kinetic energy relates to speed, Another roller coaster expert has measured kinetic energy at different speeds. They recorded their calculations on the whiteboard behind you. Have a look at the roller coaster expert's calculations. It seems we have some data on the kinetic energy of a 300 kilos object at different velocities. The roller coaster expert hasn't written down the formula of kinetic energy, but surely we can deduce it by looking at their numbers. What equation best fits the data for kinetic energy? Exactly. The kinetic energy of an object is 1/2 of its mass times its speed squared. This means that speed is a bigger factor in the kinetic energy of an object than its mass. Now you can see the equation for kinetic energy on our equation builder. Look at the equation for kinetic energy on our equation builder. Finally, we have formulas for kinetic and potential energy. The sum of the potential and kinetic energy is called mechanical energy. That means that a change of kinetic energy into potential energy or of potential energy into kinetic doesn't change the total amount of mechanical energy in a system. Now that we have formulas for potential and kinetic energy, we can start our experiments. Click on the track to begin the fun. Welcome to our testing track. On the platform to your left, you will find vehicles of 3 different masses. You can place them at any of the 3 different tracks. Pick up a vehicle and place it on one of the 3 tracks of different heights. Its potential energy will appear on the screen to your right. Try different vehicles and different tracks. Keep on experimenting with different vehicles and tracks. Every time you put a car on a track, we get a reading of its potential energy. Which track would we place a car on to give it the most potential energy? You can keep playing with the tracks if you don't know the answer yet. Well done. I'd say you are full of potential. Potential energy increases with height, so a car will reach its highest potential energy when we place it on the highest track. Potential energy also increases with mass, so the combination of the heaviest car and the highest track will have the most potential energy. Try to calculate how much energy that would be. To find the maximum potential energy, fill in the formula board to your right. Use the track as a reference and then click Calculate. You can check the height of the track and the mass of the miniature car on their tooltips by hovering over them. Yes, at this height, the car possesses 470 joules of energy, that is, the capacity to do 470 joules of work. Pull the lever to your right to release the brakes and see what happens as the car slides down the track. On the energy data screen, you can see how the potential energy changes as the car slides down the track. Look, there is no potential energy by the time the car reaches the end of the track. But it sure was going fast. Does that mean that the car has no energy at the bottom of the track? That's right, the car is moving at the end of the track, so it must have a positive kinetic energy. Now, let's calculate how much kinetic energy the car has at the bottom of the track. Use the lever to release the heaviest vehicle from the highest point again. This time watch for the final velocity at the bottom. Use this velocity to fill in the formula for the kinetic energy of the heaviest vehicle at the bottom of the track. Click Calculate when you are ready. Spot on! Did you notice that? The kinetic energy at the bottom is the same as the potential energy at the top. This means the mechanical energy of the car is the same at the top and the bottom, although it has changed from potential to kinetic energy. The car spent potential energy to get kinetic energy, kind of like when one spends money to get tickets to the roller coaster ride. From all of this, you have seen that the vehicle's potential energy was completely converted into kinetic energy by the time it reached the ground. But what about when the vehicle was at the midpoint between maximum height and zero? Place the velocity tracker at the halfway point between maximum height and zero. How much of the car's energy is potential energy and how much is kinetic when the car is at half of its starting height? Good reasoning. From the formula of potential energy, at half the initial height, the car has half of the potential energy it had at the top. If mechanical energy stays the same throughout the ride, the rest of the potential energy at the start must have been converted to kinetic energy. To see if we are right, place the heaviest vehicle at the maximum height and then pull the lever to let it zoom down the hill. Using this velocity, you can fill in the formulas for both potential and kinetic energy at this halfway point. Great work! Your experiment shows that we were right. The total mechanical energy is split evenly between potential and kinetic energy at the halfway point. Add the values of the potential and kinetic energy to get the mechanical energy of this system. Click Calculate when you are ready. And just like that, you are back to 470 joules. Remember, this is the same as the potential energy at the top of the track and the same as the kinetic energy at the bottom. Turns out the mechanical energy of the car is conserved as it slides down the test track. In our test track, mechanical energy was conserved through the ride, but I wonder if this is always the case. Is it possible for the mechanical energy of the car to change? Precisely. Friction can heat the track, converting the car's mechanical energy into thermal energy of the track. It can also warm up the car itself, exchanging some of its mechanical energy for thermal energy. No energy is lost in this process, only exchanged and converted from one type to another. From now on we will assume that friction is so small we can ignore it, and hence the mechanical energy of the car is conserved. Finally, time to apply your new knowledge to our real track. This track was pretty cool a few years ago, but now we hope you can use physics to make it even better and achieve 100 kilometers per hour. What can we change in our roller coaster design to increase the kinetic energy at ground level? That's right. At the bottom of the track, all mechanical energy is kinetic energy, and how much there is depends only on the potential energy at the beginning. What can we change in our roller coaster design to increase the speed at ground level? That's right. Kinetic and potential energy depend on mass in the same way. That means that cars that begin the ride in the same conditions will always have the same speed at the same height, regardless of their mass. That makes designing roller coasters so much easier. Otherwise, we would have to have a different track depending on how many people were riding. Put the model of the Labster roller coaster vehicle in the starting position. Fill in the formula board to calculate the initial potential energy of the Labster roller coaster. Click on the Calculate button when you are ready. You can check the height of the track and the mass of the car on their tooltips by hovering over them. Well done! Now, if the potential energy at the start of the ride is 58,800 joules, what is its kinetic energy when the car goes fastest? Exactly. At the start of the ride, all the mechanical energy is in the form of potential energy. The car is at its fastest when it is all converted into kinetic energy. We can calculate the speed of the car if we know its mass and kinetic energy by rearranging the formula of kinetic energy. Fill in the values of the mass of the car and its maximum kinetic energy on the formula board to find out the maximum possible speed of the ride. To calculate the maximum speed of this roller coaster, fill in the kinetic energy and mass on the formula board. Click Calculate when you are ready. This is the maximum possible speed, but let's see how fast the roller coaster actually goes. Place the velocity tracker at the fastest point on the pull the lever to release the roller coaster and observe the maximum velocity of this current track. If we remember that 100 kilometers per hour is 27.8 meters per second, then this roller coaster doesn't go 100 kilometers per hour yet. Looks like you will have to edit the track. From what you have learned previously, you should be able to increase the speed of the roller coaster by changing the track. Click on the section of track you could change to increase the total mechanical energy in this system. Yes. Click again to toggle between starting sections and choose the one that would give this system the highest mechanical energy. Pull the lever when you are ready. Wowza! Since the velocity reading is over 27.8 meters per second, it looks like you have achieved your mission. This is because all the potential energy the car had at the start has been converted to kinetic energy. Fantastic! Our customers are going to be super excited about this new roller coaster. Time to get back to the ticket booth. We don't want to keep them waiting. Click on the poster and we will go watch the awesome ride. Ticket sales have been through the roof because everyone is so excited about the new roller coaster you designed. Your moment to shine is finally here. Pull the lever. Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.